So yesterday in class we also summarized using our algebra tiles, or sorry, our pattern tiles, pattern blocks, the parallel line laws. So we had come up with the corresponding angles, or the F pattern, and we know that corresponding angles are equal. And we had found that by sliding one tile downwards to the other tile, it had the same angle, and the lines of course were parallel. So these are all to do with parallel lines. Down below here we have the alternate angles, and we said that the alternate angles could be called the Z pattern. And so the angles that are alternate are the angles contained in the Z, and those are equal, and we knew that from the trapezoid if we had taken the trapezoid and inverted it, as I'll show you in a second. So if we took the angle of this trapezoid and we took the whole trapezoid and we picked it up and we turned it around, then we would see that this angle fits in as well, right? So that's how we were able to label that the angle X here is 160 if we know this interior angle here is 160 degrees. So that is known as the alternate angles, or often recognized as the Z pattern. Lastly, if we summarize yesterday, we had looked at co-interior angles. The co-interior angles were angles that were inside, so these are two inside angles, and we found out that they add to 180 degrees. So we did that by looking at our pattern blocks with our rhombus, and we knew the one was 30 degrees and the other angle was 150 degrees, and yes, 30 plus 150 does add to 180 degrees, as well as 120 degrees plus 60 degrees equals 180 degrees. So if we have a set of parallel lines, I don't know, perhaps like this, and we know that this angle is 45 degrees, then we should be able to determine the missing other inside angle, because 45 degrees plus x has to add to 180 degrees. Solving then for x, I would subtract 45 from both sides, and that will leave me with 135 degrees is the angle measure for x. So that guy would be 135 degrees. So those are your C pattern, your F pattern, and your Z pattern, also known as your co-interior angles, your alternate angles, and your corresponding angles rules. So we can use those to, again, write an equation that can be solved to determine the measure of the angle. So there we go, we got to solve for x and we have to determine the measure. Actually, I guess in this case it looks like we're solving for, b. These came from course notes. So when I look at this example then, I've got this angle contained and this angle contained. And when I look at that and I've drawn that, then I see an F, or an F pattern. So that would be known as corresponding. So I'll write down that I'm using corresponding. And I know that corresponding angles are equal. So I can make the statement that 130 degrees is equal to b degrees plus 20 degrees. Oh, well then to solve for b, all I have to do is get b by itself, so that means I need to get rid of 20. And so I can get rid of 20 by just subtracting 20 degrees on this side, subtracting 20 degrees on the right hand side, but if I'm going to maintain the balance, I have to subtract 20 degrees from the left hand side as well. So that will give me then b on the left, on the right, and 110 degrees on the left. So in other words, I now know that b is 110 degrees, and if I put that into here, 110 plus 20 means that this one is 130 degrees. And that's not a really big surprise, because we already knew that the angle that corresponds to it is 130 degrees. So you're going to be working on solving problems like this on your whiteboard. Make sure that you document it, write your equation, and solve. The answers will be back on the back of the cards. Good luck.